Hey everyone. Let's see, last time we were talking about polar curves and sketching polar curves, and we did some examples, and I want to do some more examples. Today may be slightly more complicated than the examples we did last time. So remember, the idea is, if you're given some polar curve, right, that'll usually be something, it'll be something of this form, r equals f of theta. The idea is that we want to first sketch, right, in the theta r plane, and then use that, right, transfer that information to the xy plane. So for our first example today, let's do r equals cosine of theta over 2. Okay, so that's just a cosine curve, but in this case, right, when we do a theta over 2, what it does is it slows down the period. And so what I'm going to do now in this case, normally I just need to go to 0 to 2 pi. In this case, I actually need to go to 4 pi, right, to get an entire cycle of this graph right here, right? So I mean, it just looks like a standard cosine curve. But to complete one period, right, we have to go all the way up to 4 pi. And now I'm going to mark some of the standard spots here. So this would be at 2 pi. And when I say standard, meaning I want to mark the standard, the common angles that we're interested in. So let's see, this would be pi. I'm going to mark pi over 2. I guess it looks a little lopsided, doesn't it? But so, sorry, 3 pi over 2 is right there. And then there's a 5 pi over 2. That's at 3 pi. That's at 7 pi over 2 right there. Okay, now we're going to do the same thing. I'm just going to do it bit by bit. So the first thing I do, and I should point out, it's possible that I did too much, that I don't need all of this, but I at least want to see one complete cycle of whatever graph I use. Sometimes it'll start repeating itself so that I can say, oh, this is redundant, but it's better to do more than less, or do too much than not enough. So starting off with pi over 2, right, if I look at this segment right here, let's label that little a, and what we have is our radius is going, as we go from, as theta goes from 0 to pi over 2, our radius starts off at 1, and then we get cosine of pi over 4, so that's a root 2 over 2, right? So what happens then as we go from, from 0 to pi over 2, the radius goes from 1 to root 2 over 2. Root 2 over 2, I think, is somewhere around 0.7. So if this is distance 1 right there, then root 2 over 2 is something like that. So, right, so we have a picture like that. Okay, so now for the next segment, right, so let's call that little b. Oh, let me label this little a. So now as theta goes from pi over 2 to pi, our radius is going from root 2 over 2 down to 0. So as we sweep out the second quadrant, our radius decreases until we're at 0. Okay, so now as we go, so let's label, let me label that part B. Okay, so now as I go from pi to 3 pi over 2, right? So that means as we go through the third quadrant, the radius is going from 0 to negative root 2 over 2. So let's see. If I'm sweeping out the third quadrant, but my radius is negative, that means that I'm drawing in the first quadrant. And so what we have, it's going from 0 to negative pi over 2. So that's what we get right there. Then, as we go from 3 pi over 2 to 2 pi, right? So now we're going through the fourth quadrant. Our radius is going from negative root 2 over 2 to -1, right? So as I travel through the fourth quadrant, I'm drawing in the second quadrant. So it looks like that. And so that's part D. All right, so now you can probably just by using symmetry see what this is going to look like as we go through the from 2 pi to 5 pi over 2. All right, so what is that? That's traveling again through the first quadrant. We've got a negative radius. We go from 1 to root 2 over 2. -1 to negative root 2 over 2. Like that. So that's part E. And now I think you can see what's going to happen. So for part F, we're going from negative root 2 over 2 back to 0. So as we go through the second quadrant, I'm drawing in the fourth quadrant like that. So there's F. And then there's going to be a G and an H, right? The G, as we go through the third quadrant, radius goes from 0 to root 2 over 2. All right, and then it finishes off like that. So that was G and H, like that. I made my graph maybe a little bit lopsided, but hopefully you get the idea. I guess it really should be more like that. So typically, we like to have graphs of functions, right? And R on the left-hand side, f of theta on the right-hand side. But that's not always possible. And so in this next example, we're going to see something where it's not quite like that, but we can still sketch the graph, right? So in this example, what I want to do is r squared rather than r. R squared equals sine theta. Okay, now the first thing to observe, right? R squared is always greater than or equal to 0, which means that sine has to be, our right-hand side has to be greater than or equal to 0 also. Right, so let's note we need sine theta to be greater than or equal to 0, right? Because it doesn't make sense to have a positive number equal to a negative number. So if you think about the sine graph, right, it's positive from 0 to pi, right? So we consider our theta values from 0 to pi. And in that case now, I can take the square root. So what I get is r equals square root. Well, I gotta be careful. R equals plus or minus square root of sine theta. Okay, so now I'm going to actually do this I'm going to do it in 3 steps here. So first of all, the graph of sine, right, looks like that, where there's 2 pi, there's pi over 2, here's 3 pi over 2. And notice we only care about this first chunk right here, right? Right, because we don't want the negative theta value, so we're only looking at this left-hand portion right there. Okay, so now let's say how to make use of this information right here to graph r equals plus or minus square root of sine theta. So I'm only going to go to pi. And what's happening here, or what happens as you take, so if you take the square root of a number between plus and minus, take the square root of number between 0 and 1, right, what happens, it gets slightly bigger. So what it does is it takes this graph, if you imagine taking the square root of that graph, what it does is it just rounds it out a little bit. Like that. Right, so this is the graph of r equals square root of sine theta. Of course, there's also the negative version, and that'll be right down there. Right, so here is r equals minus square root sine theta. So together, this is the curve corresponding to r squared equals sine theta. Now remember, this is happening in the theta r plane. Now we want to translate this information to the xy plane. And so let's see what happens as, just focusing on the top half, as theta goes from 0 to pi over 2. What we have is a radius starting at 0, ending at 1, And then as we go from pi over 2 to pi, it's going from 1 back down to 0, right? So as we sweep out the first two quadrants, right, we get this. At the same time, looking at the negative portion, as we go from 0 to pi over 2, we have a radius that's going from 0 to -1. And then from -1 back down to 0. All right, so these happen simultaneously. And let me just give you an indication of how the, if you want to think of this as movement, right? It's a sense of direction, right? So this is in the xy plane, the graph of r squared equals sine theta. And let's do a couple more examples. The next one, r equals 1/2 plus cosine theta. So what is this going to be? It's going to be a cosine graph, but it's shifted up half a unit. So I'm going to draw a little dividing line here. So the cosine graph, this is at 1/2 here, the cosine graph would go like that. I've exaggerated a little bit. So let's see, this is happening at pi over 2. This is at pi. This is at 3 pi over 2. Here's 2 pi. And then I'd also like to know where it crosses the x-axis. Or sorry, the theta axis. And so let's see, how would you solve that? You would set this equal to 0. Right? So if we do cosine theta, set this equal to 0, that would be cosine theta equals -1/2. So where does that occur? Well, that's going to occur at what? 2 pi over 3 and 4 pi over 3, right? So that one's 2 pi over 3. And that intersection point right there is 4 pi over 3. Okay, so now we want to take this information, transfer it to the xy plane. So let's see, as we sweep out the first quadrant, as theta goes from 0 to pi over 2, we're going to go from 3/2 to 1/2. And remember, this doesn't need to be perfect. We're just measuring the radius, right? So there's a radius, right, of a little less than 3/2, getting smaller, 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 smaller. We're always measuring from the origin to the curve, right? By the time we're pointing straight up, we want to have a distance of 1/2. Then as we go from pi over 2 to 2 pi over 3, right, so that's an angle of 2 pi over 3 here, our radius is going from 1/2 to 0. Looks like that. Hope I hit that a little too sharp. I need to stay inside there, sorry. There we go. Okay, then as we go from 2 pi over 3 to pi, so as we sweep out this portion right here, we have a negative radius, right? It's going from 0 to -1/2. So we're sweeping out this portion of the second quadrant, which means that we're going to be drawing in the fourth quadrant, like that. And then as we go from pi to 4 pi over 3, our radius is going from -1 back to 0, so it completes a little loop like that. And now as we finish this off, we're back in the positive, right, where we get back to a positive 1/2 right there as we go from 4 pi over 3 to 3 pi over 2. And then to finish it off, from 3 pi over 2 to 2 pi, so as we go through the fourth quadrant, it looks like that. Now, this is obviously kind of an ugly, a lot of times when I do it the first time, it looks a little bit misshapen, right? And then I try to smooth things out a little bit afterwards. Right? That's a little better. Right, but there's the idea. And one thing to remember, these don't have to be perfect. These are sketches, right? You don't need to be artists. What I want when you're doing a quiz or a test, you want to identify the key features of these graphs, right? And how do you find the key features of this curve here? It's by understanding how to sketch in the r theta, or the theta r plane first. Okay, so I'm going to do one more example, and this one's going to require you to to really know your trig values. So this is going to be r equals 1 plus 2 sine 2 theta. Okay, so what do we have? We have, let's see, we take a sine curve, we double the amplitude, and then shift by 1. Right, shift up by 1. The 2 theta part doubles the period, so I'm going to do 2 sine curves. Let's see, this is going to go up to a maximum of 3. The minimum is minus 1, and then at positive 1 we kind of have the dividing halfway point. And so let's see. I think I want to, let me stretch things out a little bit. Sorry, I'm going to redo this just to make the graph look a little better. Okay, so there's one period, and then there's a second period. So let's see, our first maximum occurs at pi over 4. So here's what I want to mark. I want to mark the places where it crosses this axis right here, the y equals 1 axis. And so let's mark these various points here. So let's see, it's going to cross, that's going to be at what, pi over 2. Then it's going to have a minimum at 3 pi over 4. It's going to cross right here at pi. This the maximum will be at 5 pi over 4. And then this is at 3 pi over 2. We've got the minimum at 7 pi over 4. And there's 2 pi. Okay, I want to mark those spots, but I also want to mark the spots where it crosses the actual theta axis. So there, there, and there. So let's see how you'd figure this out. Well, this is going to correspond to when r equals 0. And so what we would have is sine 2 theta equal to negative 1/2. So let's see. Okay, so where's sine 2 theta equal to negative 1/2? Well, 2 theta would have to be, let's see, the first time would be at, let's see, so that's at 7 pi over 6. So yeah, 7 pi over 6, and then again at 11 pi over 6. And then add, so then what's this? Add 2 pi to that, so that's going to be 2 pi is 19 pi over 6. And then, am I getting this wrong? Let me just check my notes. Is it? Yeah, 19, and then the last one is going to be, so add 2 pi to this one, so that would be 23, this should be 6 right there. This last one should be 23 pi over 6. And so that tells me then that so divide everything by 2, right? That's going to tell me that this one right here is 7 pi over 12. That one right there is going to be 11 pi over 12. And then I get 19 pi over 12. And here is going to be 23 pi over 12. Okay, so now we've marked the key features of this graph, and this is everything that we need to know, right, to sketch in the xy plane. Okay, so what do we have? From 0 to pi over 4, we're going to have a radius going from 1 to 3. So at an angle of pi over 4, we're going from, so we start off at distance 1, and we're going to end up at distance 3 from the origin. And then as we go from pi over 4 to pi over 2, we're back down to 1. So there's 1, like that. And then from pi over 2 to 7 pi over 12, we're going from a radius of 1 to a radius of 0. So 7 pi over 12 is what? Well, I guess it's just a little bit. It's just like that. And so it keeps going down, 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 down. And by the time we're at an angle of 7 pi over 12, we're at the origin. Okay, so now we're going negative from 7 pi over 12 to 3 pi over 4. So as we sweep out this angle right here, we are negative. And we're going from 0, yeah, we're going from 0 to minus 1. And so 0 to minus 1. And then from 3 pi over 4 to 11 pi over, oh, that should be 11 pi over 12. Which is where? It's over here. Right, so from 3 pi over 4 to 11 pi over 12, we're going back to 0. Right, so we go from 1 to 0 right here. Then from 11 pi over 12 to pi, which is this portion right here, now we've got a positive angle. It's going from 0 to, or sorry, positive distance, positive radius, so going from there to 1. And then from pi to 5 pi over 4, we're going from 1 out to 3. And then from 5 pi over 4 to 3 pi over 2, we're going from 3 back to 1. And now hopefully you can kind of see what's happening. This one I made a little bit too lopsided here. And then if we finish this off, so let's see what happens next. From 3 pi over 2 to 19 pi over 12, we're going down to 0. So we're going to kind of come like this. Then we're going to finish, okay, so from 19 pi over 12, I'm just going to do the whole thing, to 23 pi over 12. We've got a negative radius, and so that means that we're going to draw another little mini loop like that. And then from 23 pi over 12 to 2 pi, so from this little part right there, we finish it off. That one's a little bit tricky, right? It's got some smaller, tighter angles, but if you keep your head straight and just follow what this graph tells you what to do, right, it will tell you exactly how to sketch this curve. All right, so that's a good place to stop. Your homework for 14, I guess homework number 14 is going to be all about sketching curves. We're going to need to be able to do this because the next thing we're going to talk about is finding the area enclosed by various polar curves. So we'll need to be able to sketch the polar curves and understand how they work before we can find the area inside. All right, so we'll see you next time.